On the morning of October 29th, telescopes across 3 continents opened their domes to the same target, a faint, irregular point of light racing toward its closest encounter with the Sun. The object known as 3I Atlas, officially catalogued as the third interstellar visitor ever recorded, was reaching its perihelion, the moment when its trajectory would skim nearest to the heart of our solar system. For astronomers, perihelion is not merely a milestone of orbital mechanics. It is a stage, a test, a revelation. Under the crushing heat of solar radiation, an object bears its true nature. Ice becomes vapor, dust becomes plume, and what was once a silent traveler erupts into visible life. At least, that is what the textbooks tell us should happen. Yet this time, the cosmos whispered something different. 3I Atlas had already drawn attention for months before that day. Its path, its brightness curve, and its spectral fingerprints had refused to behave like those of any ordinary comet. The community expected fireworks, a surge of brilliance, a roaring outburst of gases as it brushed through the furnace of sunlight. Instruments aboard NASA's Solar Dynamics Observatory, the European Space Agency's Solar Orbiter, and dozens of ground-based facilities stood ready to capture the explosion of activity. But as the data began to arrive, the collective breath of the scientific world seemed to still. Instead of flaring into radiance, the object dimmed. Its glowing coma, which had expanded steadily through its approach, began to shrink. Within a span of only 6 hours, its brightness fell by nearly half. The numbers scrolled across screens in laboratories from Pasadena to Paris, and disbelief echoed in every discussion channel. Something fundamental was wrong. This was not a minor deviation, not a measurement quirk to be smoothed away with calibration. Comets are predictable in their chaos. When sunlight strikes their frozen nuclei, subsurface ices boil off, driving jets of vapor and dust into space. The closer they draw to the sun, the more ferociously they vent until a vast, luminous envelope forms, the coma, and a sweeping tail arcs behind them. At perihelion, energy input reaches its peak. The result should be maximum activity, not silence. Yet 3I Atlas behaved as though it sensed the oncoming heat and responded by withdrawing, closing itself off, reducing its own energy output as if guided by an internal command. That suggestion alone unsettled every seasoned astronomer reviewing the figures. Natural bodies do not decide how to react to radiation. They follow physics, not instinct. In the early hours after the anomaly appeared, observatories exchanged terabytes of data. Spectrographs compared the object's composition before and during perihelion. Initial readings showed familiar cometary gases, water vapor, carbon monoxide, carbon dioxide, traces of organic molecules. But at the very moment of closest solar approach, those familiar markers faded, replaced by strange emission lines that defied identification. Complex hydrocarbons, nitrogen compounds, and wavelengths corresponding to no known molecules appeared in the spectra. Every chemical model failed to reproduce them. For researchers trained to find patterns in noise, this was not random scatter. It was structured, deliberate, coherent. As the days passed, new layers of confusion accumulated. Infrared observations indicated that the surface of 3I Atlas maintained an almost perfectly uniform temperature across its entire visible face, within 2 degrees Kelvin of variation. That kind of thermal balance should be impossible for a naturally shaped rock composed of mixed materials. Uneven heating, localized hotspots, and variable emissivity are the norm. Uniform temperature implies either an extremely homogeneous composition or some mechanism actively redistributing heat. Neither possibility fit with existing data. The object's albedo, a measure of reflectivity, had also changed rapidly, doubling within less than 8 hours. No known comet alters its reflectivity on such short timescales. Each of these results, standing alone, might have been dismissed as a quirk of instrumentation. a statistical aberration. Together, they painted an image that challenged the very definition of what a comet is. As sunlight streamed past the object, the universe appeared to perform an experiment on our assumptions, and humanity, watching from a small blue world orbiting 93 million miles away, found itself asking the oldest of questions in a new form. What, exactly, are we seeing? For the first time since the discovery of interstellar object Oumuamua years earlier, the word artificial began to creep into academic discussions, not in headlines or forums, but in quiet, careful phrases spoken between researchers who understood how dangerous speculation could be. Was 3I Atlas a natural wanderer, shaped by processes beyond our experience, or something else entirely? Something built, not born? No one dared to claim it outright, yet the silence that followed each new data release carried the weight of that possibility. As the sun's light bent around the tiny visitor and instruments continued to record its retreating glow, a sense of awe replaced the earlier confusion. Something had happened at perihelion that defied explanation, something that hinted at mechanisms, materials, or perhaps intentions we did not comprehend. Scientists began to revisit every assumption, recalibrating theories that had seemed unshakable for decades. The universe had presented a riddle, and behind that riddle was a truth that could alter not just our models of cometary behavior, but our understanding of life, intelligence, and our own place among the stars. The story of 3I Atlas was no longer a footnote in astronomy. It was becoming a mirror, reflecting the limits of our knowledge and the magnitude of the mysteries that still surround us. And as data continued to flow in, one question grew louder in every observatory, in every late-night meeting, in every mind attuned to the skies. What if this object was never a comet at all? Next, when the first analyses of 3I Atlas's perihelion data reached the scientific networks, what began as curiosity transformed into a state of global astonishment. Laboratories in Hawaii, California, Darmstadt, and Tokyo confirmed that the sudden dimming observed near the sun was real and not an artifact of instrumental error. The drop in luminosity by nearly 40% within 6 hours was validated independently by more than a dozen observatories. This meant that what humanity had just witnessed was an authentic physical event, not a glitch in the machinery of observation. From that moment onward, the narrative surrounding 3I Atlas shifted dramatically. It was no longer a routine interstellar comet. It became an enigma capable of rewriting the language of astrophysics. NASA's Solar Dynamics Observatory, orbiting Earth in geosynchronous alignment, provided the most detailed ultraviolet imagery ever obtained of a cometary perihelion. The images revealed that as 3I Atlas entered the zone of maximum radiation flux, the outflow of material abruptly halted. Jets that had been venting from subsolar fissures simply ceased. The coma, once expansive and diffused, contracted inward, creating a dark halo that seemed to absorb rather than scatter sunlight. This phenomenon defied every known model of volatile sublimation. The European Space Agency's Solar Orbiter, stationed in a complementary orbit closer to the Sun, recorded a similar observation. The spectral brightness of ionized oxygen lines plummeted to almost background levels precisely when they should have peaked. At the same time, ground-based radio telescopes in Chile and South Africa detected unexpected shifts in the object's emitted thermal spectrum. Instead of the irregular, spiked pattern associated with dust and gas ejection, the infrared curve became smooth and stable, corresponding to a body maintaining constant surface temperature. The uniformity was remarkable. Normally, as a comet rotates, different regions warm and cool, producing thermal variations that instruments can easily detect. 3I Atlas exhibited none. Every part of its surface radiated as though locked to a precise energy balance. For the scientists interpreting these data, one explanation loomed uncomfortably large: active heat regulation. Dr. Robert Warwick at the University of Hawaii's Institute for Astronomy took responsibility for dissecting the spectral anomalies. Working through the night with his team, he compared the observed wavelengths against known molecular databases: water, carbon dioxide, methane, ammonia, cyanide radicals, organic hydrocarbons. The patterns refused to fit. New emission lines appeared near the 2.1 and 3.6 micron regions, showing structures inconsistent with any stable molecular vibrations recorded in laboratory conditions. Warwick's final report to NASA's Planetary Science Division concluded that the spectra do not correspond to any known combination of naturally occurring volatile compounds. He added, almost reluctantly, that the features suggest transitions associated with engineered or highly ordered materials. The statement reverberated through the astrophysical community. Engineered materials. The phrase appeared in internal memoranda, always with disclaimers, yet it marked a subtle breaking point. The data implied that the surface of 3I Atlas contained arrangements of matter unknown in natural cometary bodies. Infrared polarization analysis strengthened this suspicion. Normally, light scattered from dust particles produces a specific polarization angle based on size and composition. The light from 3I Atlas, however, maintained consistent polarization regardless of observation angle, as though the surface consisted of aligned microstructures, perhaps arrays, perhaps panels, reflecting light in a coordinated pattern. Further perplexity came from the Parker Solar Probe, whose magnetometers happened to pass within 2 million kilometers of the object during perihelion. The probe detected a distinct magnetic field emanating from the direction of 3I Atlas. Unlike the weak-induced magnetism produced when solar wind interacts with a coma, this field had an organized, pulsing structure. It oscillated with a period of 4.7 seconds. Nothing in nature behaves like that at such a small scale. For a body only a few hundred meters across to generate a measurable magnetic oscillation, it would need a mechanism for circulating electrical current. Essentially, a dynamo. Parker's data showed the field increasing and decreasing in a pattern too regular to be random. Astrophysicists proposed several theories to explain it. Some hypothesized piezoelectric effects within crystalline silicates. Others suggested charge differentials caused by rapid rotation. But simulations proved these insufficient to produce the observed amplitude. The only plausible explanations required directed electrical flows, meaning moving charges along paths, something like circuitry. The idea was whispered, not published, but it lingered in every conversation. Could this small object actually be powered? As if that were not enough, the trajectory analysis deepened the crisis. Using data from the Minor Planet Center and the Jet Propulsion Laboratory's Horizon system, orbital specialists recalculated the predicted path of 3I Atlas before and after perihelion. The deviation was enormous, 800 kilometers off the expected course. That discrepancy could not be attributed to gravitational perturbations. All nearby planetary influences were already accounted for. Nor could outgassing forces explain it, since the object's venting had ceased. Something had imparted a measurable impulse at the exact moment of perihelion. To produce such a change without visible exhaust would require either the ejection of mass from an unseen direction or the operation of non-reactive propulsion, perhaps electromagnetic or photon-based. Yet there were no corresponding spikes in radiation detectable by any instruments. The deviation simply appeared as though the object had made a subtle correction to its own trajectory. Even conservative analysts struggled to reconcile the data. In their private communications, many admitted they had never seen anything like it. By early November, agencies convened emergency teleconferences. Representatives from NASA, ESA, the Chinese National Space Administration, and JAXA compared findings. While official statements referred to unusual physical phenomena, Internal summaries described structured anomalies indicative of non-natural dynamics. One European scientist was recorded saying, "Either our physics is missing a law or this thing is alive." The remark was metaphorical, but it captured the unease spreading across the global research community. The conversation soon turned to the chemical fingerprints that had emerged during perihelion. Spectral analysis revealed transient peaks at wavelengths associated with complex aromatic hydrocarbons, molecules that could form in high-temperature synthetic environments but not through ordinary cometary chemistry. There were also narrow-band emissions at frequencies suggesting the presence of nitrogenated carbon chains more complex than any previously found beyond Earth. Some scientists proposed exotic polymerization under solar radiation, yet the timescale was too short. The molecules appeared and vanished within minutes, implying active synthesis and breakdown. The possibility of controlled chemical reactions could no longer be ignored. Further puzzling data came from photometric observations of the object's albedo. Between the inbound and outbound legs of perihelion, reflectivity more than doubled, from 0.04 to 0.09. Such a change implied that the surface had physically transformed, either by exposing new layers or altering its texture. But high-resolution imaging from the solar orbiter showed no mass ejection or fragmentation that would account for the brightening. Instead, the entire visible hemisphere seemed to shift toward higher reflectivity, as if coated by a thin, uniform film. On Earth, that kind of change could be achieved by deploying reflective panels or by self-cleaning surfaces that shed dust layers under heat. The analogy was unsettling. Amid the growing uncertainty, a small group of researchers within NASA's Goddard Space Flight Center began to consider unconventional hypotheses. Led by Dr. Elaine Hartsfield, the team examined whether the object could contain internal cavities or structures. Using radar echo modeling, they inferred that 3 I-Atlas possessed regions of anomalously low density distributed symmetrically along its core. Natural comets often contain voids, but never with such symmetry. The data hinted at internal chambers, hollow zones, too evenly arranged to be the product of random formation. Hartsfield's group carefully avoided speculative language, but their private correspondence revealed their struggle. "It behaves like a designed system," one engineer wrote, "not a pile of rubble." As scientific papers began to circulate in preprint form, journals faced an editorial dilemma. How does one publish evidence that points toward possibilities bordering on the extraordinary? Most editors opted for caution. They framed the findings as evidence of non-standard cometary physics, avoiding any mention of artificial origin. Yet behind the scenes, conversations grew bolder. Could 3 I-Atlas be an interstellar probe, a relic of a civilization long vanished? Or was it an entirely new category of cosmic object, something we had no vocabulary for yet? The data from the Solar and Heliospheric Observatory added another layer. Its coronagraph captured a faint, structured halo around the object, distinct from dust or plasma tails. The halo contained repeating brightness variations spaced evenly, forming what looked like concentric interference fringes. When transformed into frequency space, the pattern resembled modulation, a signal imprinted on reflected sunlight. Radio astronomers attempted to decode the sequence, but found no intelligible pattern, only rhythm. It could have been coincidence, a trick of light and geometry, or it could have been a deliberate modulation meant to be noticed. In December, the International Astronomical Union hosted a closed session on the findings. Participants presented competing models, one rooted in advanced cometary physics, another suggesting self-regulating thermochemical processes, and a third exploring the notion of artificiality. The debate was intense but respectful. For many attendees, the subject evoked memories of the Oumuamua controversy years earlier, when scientists hesitated to label anomalies as anything beyond unusual natural phenomena. But the evidence for 3I Atlas was far richer, far harder to dismiss. Some researchers proposed that the object could be a fragment of an ancient interstellar craft, eroded and inactive, yet still containing residual systems that respond autonomously to environmental stress. Others speculated it might be a probe using unknown propulsion methods, perhaps magnetic field interaction with solar plasma. A smaller but vocal group maintained that it was a purely natural interstellar object whose composition simply falls outside our known chemistry. They argued that assuming intelligence without proof would set a dangerous precedent. Nevertheless, the conversation had already changed. 3I Atlas was no longer just another interstellar visitor. It had become a mirror reflecting the limits of our scientific imagination. Its silence at perihelion, its pulsing magnetic field, its impossible thermal uniformity, all suggested a complexity that demanded direct investigation. Mission concepts were drafted in haste. NASA's Interstellar Object Rapid Response Office proposed a small, fast probe capable of intercepting the object within 18 months. The plan called for ion propulsion, autonomous navigation, and a suite of instruments designed to capture high-resolution imaging and magnetic mapping. ESA discussed collaborating on a complementary observation mission from the Solar Orbiter platform. China's National Space Administration publicly expressed interest in launching its own intercept probe, citing historic scientific value. The race to study 3I Atlas had begun, even as many still debated what it truly was. Yet beyond the plans and proposals, a deeper sentiment took hold among those studying the data. There was a sense of unease, a feeling that humanity had brushed against something vast and incomprehensible. If 3I Atlas was artificial, its silence might not be indifference, but intent. Perhaps it was observing, perhaps it was listening, or perhaps it was simply malfunctioning, the fading echo of a civilization that vanished before Earth had even formed continents. Whatever the truth, the object had forced humanity to confront a possibility that had long lingered at the edge of scientific thought. We are not alone, and the universe may have left us messages drifting quietly through the dark. For now, the evidence remains unresolved. The official stance of major agencies still classifies 3I Atlas as a cometary body exhibiting nonlinear thermophysical behavior. But the data tell another story, one written in the language of paradox. A body that cools under heat, that brightens while going dormant, that moves with precision yet shows no thrust, that sings in magnetic pulses every 4.7 seconds as it sails beyond the reach of our instruments. The perihelion of 3I Atlas has ended, but its implications are only beginning. Somewhere in the black gulf beyond Mars, it continues outward, carrying its secrets away from the sun, while on Earth our telescopes follow. Our scientists argue, and our imaginations awaken to the enormity of what we may have just encountered. And as the faint speck drifts farther from our world, a quiet realization settles among those who have seen the numbers and the light curves and the spectral signatures. Perhaps this was never a comet song at all. Perhaps just for a moment we overheard the whisper of something ancient, deliberate, and watching. In the months following perihelion, as 3I Atlas receded into the outer solar system, the world's telescopes continued to trace its dimming light. What had once burned with enigmatic brilliance now shimmered faintly against the backdrop of stars, yet the questions it left behind glowed more fiercely than ever. In the scientific community, debates over its nature no longer centered on whether something strange had occurred, but on what that strangeness meant. To understand the story now, we must step back and look at the broader arc of how humanity has reached this point, an era when even the faintest light from space can shake the foundations of what we believe about ourselves. The story of 3I Atlas cannot be told without recalling the instruments that first saw it. The Pan-STARRS Observatory in Hawaii, whose wide-field cameras once discovered the first interstellar object, Oumuamua, had catalogued countless transient phenomena, yet none had challenged understanding like this one. When Pan-STARRS first picked up 3I Atlas months before perihelion, its apparent brightness curve suggested a conventional cometary nucleus, roughly 400 meters wide. Its orbit traced a hyperbolic trajectory, meaning it would never return. It was simply passing through, a visitor from the interstellar deep. But even in those first observations, peculiarities were evident. Changes in rotation rate inconsistent with outgassing torque, and faint fluctuations in reflected light that hinted at structured surfaces rather than chaotic ones. By the time perihelion came and went, the world's greatest minds were engaged in decoding the mystery. One of them was Dr. Elaine Hartsfield, the NASA systems engineer who had spearheaded the radar analyses revealing possible internal cavities within the object. Hartsfield's career spanned 3 decades of spacecraft design, from the Parker Solar Probe to the Lucy mission to Jupiter's Trojans. She was not a person prone to speculative thought, yet the numbers forced her into unfamiliar territory. The echo patterns, she explained in a later lecture, behaved as though they were bouncing off ordered boundaries, not random fractures. It looked engineered. She paused before adding, almost to herself, or at least organized by some principle we don't yet recognize. For Hartsfield and others of her generation, 3I Atlas became more than a research subject. It was a mirror reflecting the limitations of human comprehension. The object defied the dichotomy between natural and artificial, between chaos and intention. It seemed to occupy a realm in between, as if the universe itself were reminding us that such boundaries are products of our imagination, not of cosmic law. Scientists began to revisit older theories about panspermia, self-organizing systems, and the possibility that intelligence could arise not through biology but through physics itself, a form of emergent order encoded into matter. Could 3I Atlas be an artifact of such a process, a fragment of intelligent matter formed not by hands but by natural laws that once gave rise to life elsewhere? Meanwhile, space agencies confronted a dilemma of purpose. The data demanded direct observation, but the target was fleeing. At 20 kilometers per second, each day widened the gulf between Earth and the object by over 1.5 million kilometers. Plans for a pursuit mission raced against that inexorable clock. NASA's proposed flyby, dubbed Project Vespera, envisioned a compact probe launched by a Falcon Heavy-class rocket, using solar sails for acceleration and an autonomous navigation suite capable of high-velocity rendezvous. The design borrowed from the interstellar probe concepts that had been on hold for years, suddenly revived by the urgency of this event. Across the Atlantic, the European Space Agency considered a collaboration under the working title Aurora, while Japan's JAXA explored the possibility of contributing spectrometers and imaging payloads. But as technical designs circulated, another voice emerged in the conversation, that of Dr. Robert Warwick, whose sleepless nights had produced the first detailed spectroscopic comparison of 3I Atlas. Warwick was an astrophysicist known for his calm pragmatism, a man who measured words as carefully as light curves. In a symposium held at the California Institute of Technology, he addressed a packed auditorium. "We must be cautious," he said, "not to mistake mystery for message. Yet we must also not dismiss the possibility that we have encountered something made." His words carried the weight of both humility and awe. He proposed a radical but simple principle: treat the object as neither comet nor craft, but as data, an encoded fragment of the universe itself. "Every anomaly," he continued, "is information. Our job is not to explain it away, but to listen." The idea of listening resonated deeply with the new generation of scientists. Radio arrays tuned themselves to the frequencies associated with the object's magnetic oscillations. They sought patterns in its pulsing 4.7-second cycle, correlations that might hint at underlying systems. Though no signal emerged in the conventional sense, subtle modulations appeared in the electromagnetic spectrum, quasi-periodic disturbances that seemed to adapt as the object moved farther from the Sun. Some analysts described it as resonance, others as feedback, perhaps even response. It was as though the object were reacting to solar decline, adjusting its internal equilibrium. For those drawn to poetic interpretations, 3I Atlas became a metaphor for endurance, a silent traveler preserving itself through the extremes of heat and cold. For engineers, it represented the ultimate challenge, a puzzle in which every equation refused closure. And for the dreamers who had long imagined humanity's first contact with something beyond itself, it carried an almost spiritual gravity. If the object was indeed artificial, it might have crossed interstellar space for millions of years. Its creators could be gone, their civilization long extinct, yet their technology continued to function, following programmed instructions written before human beings learned to speak. To encounter such a relic would be to touch the memory of a vanished mind. The emotional weight of that possibility reached beyond science. Artists, philosophers, and writers began to reference 3I Atlas as a symbol of cosmic solitude. Documentaries revisited the footage of its approach, layering it with somber music and slow narration. The public, too, felt the pull of wonder and uncertainty. Could it be that we had just glimpsed proof that intelligence is not unique to Earth? Or were we witnessing something more profound? A natural intelligence embedded in the physics of the universe itself. In private, mission planners struggled against time. Even as proposals solidified, funding remained uncertain. The political appetite for a billion-dollar pursuit of what might be a natural comet was fragile. Yet support grew among those who saw the event as a defining test of human curiosity. "If we let this go," Hartsfield wrote in an open letter, "we surrender the spirit that built the telescopes, which found it." Her words echoed the ethos of the space age, that exploration is not driven by certainty, but by the willingness to confront the unknown. As winter turned to spring, new data arrived from the Parker Solar Probe, now transmitting the last of its magnetometer readings. The oscillations persisted, though diminished. Their regularity had changed subtly, the 4.7-second cycle stretching to 4.9. Some interpreted this as signal degradation, others as evidence of energy loss. The object was cooling, its systems, if systems they were, slipping into dormancy. The notion of a machine drifting into eternal silence, still functioning just enough to maintain equilibrium, evoked both melancholy and reverence. If 3I Atlas was alive in any sense, it was now falling asleep. And yet, from that fading light, hope continued to grow. At the Jet Propulsion Laboratory, engineers began preliminary simulations for an intercept trajectory that could catch up with the object within 12 years using advanced solar electric propulsion. The plan would require cooperation across nations, a unifying project in a time of global division. For once, the cosmos offered a goal beyond politics, beyond competition. A mystery so vast that it demanded humanity act as one species, not many. What 3I Atlas ultimately represents may never be fully known. It might be an interstellar artifact, an ancient probe whose creator's language has long since dissolved into cosmic dust. It might be a natural formation whose materials obey physical laws yet undiscovered. Or it might be something that blurs those distinctions entirely. A bridge between matter and intention, between creation and emergence. Whatever it is, it has already changed us. It has reminded us that the universe remains incomprehensibly vast and that our understanding of it, though profound, is still in its infancy. In the final analysis, perhaps the true revelation of 3I Atlas lies not in what it is, but in how we responded to it. Faced with data that defied expectation, humanity did not look away. We questioned, we doubted, we dreamed, we built theories, we designed missions, we reopened the ancient conversation between curiosity and fear. That too is a kind of contact, not between species, but between our present selves and the potential of what we might become. Even now, as 3I Atlas drifts outward past the orbit of Jupiter, instruments continue to listen for its pulse. Some nights, when the background noise of solar wind dips low enough, radio telescopes still register the faint echo of its magnetic rhythm, a heartbeat at the edge of comprehension. Whether it is a machine, a rock, or a relic, it continues to move. A silent traveler, bearing witness to the star that warmed it and to the civilization that briefly noticed its passing. Perhaps, in the distant future, when our own probes venture into interstellar space, they too will glide past other suns, their signals weak but persistent, carrying traces of who we were. And somewhere in that great expanse, maybe 3I Atlas will still be traveling, unchanged, ancient and indifferent, yet eternally linked to the moment we looked at it and realized how much we still have to learn. In that sense, the story of 3I Atlas is not about aliens or comets. It is about us, about the fragile spark of intelligence that dares to wonder. The object may one day fade entirely from detection, but the question it left behind will not. It will echo through observatories and classrooms and dreams for generations. What if, amid the silence of space, something looked back? And what if, just for an instant,